Good morning. Today we are going to learn about numbers. That is basically numbers theory. Basically now when somebody says about numbers, they feel what exactly this person is going to talk about numbers. These are the common things I know. But you see, there are certain things which you are supposed to know in a very good way. You see, everybody is familiar with the numbers, but we have to make them more familiar. We have to make them very close to us and make it interesting. Okay, so now in number theory, I am basically what exactly we are going to learn today. So today we will be learning what types of numbers are there. So I will just write down here what types. Okay, what types of numbers are there, then how we are going to write the numbers, how to write the numbers. And basically why we are learning this number theory. Okay, why we are learning the number theory. So see, these are the basic three things which we are going to learn today. Okay, so now first let us take what types basically. Okay, now what types means, you see, there are basically the numbers are subdivided into two categories. Okay, so now these two categories are real numbers and imaginary numbers. Okay, so I will just write here for your information. So what type? So first thing is, there are two subdivisions we can say. One is the real, okay, and the second will become imaginary numbers. Okay, so there are two subdivisions for the types of numbers. One is a real number and the second is the imaginary numbers. Okay, now today's lecture we are restricting ourselves only to real numbers, because imaginary number at present is out of focus for us. It is out of, we can say, syllabus. So that we will learn as and when we are talking about imaginary numbers and complex numbers. Fine. So we will now just think about the real numbers. Again, what are the subdivisions of real numbers and imaginary numbers? That is the first part. Now the second part, so we'll come one by one. What is the second part? How to write the numbers. Basically, what is the meaning of how to write the numbers? Basically, writing the numbers, you know that you have to have some starting point, and that starting point or a benchmark, we say starting point. So that is zero. We always say zero is the starting point. And if you are writing something to the right side of 0, they are all positive numbers, and to the left side of 0, they are all negative numbers. So then, basically that is the way to write, right? Fine. So why we have to learn about the positive numbers, negative numbers, and 0? Because there are so many of mathematics where you have to learn. For example, in coordinate geometry, you must know, because there is a number line, horizontal number line and vertical number line. But today we are restricting ourselves only to a horizontal number line, because that is what we are actually basically learning about the number theory. But in coordinate geometry, the applications, why we are learning basically how to write the numbers. As I said, 0 is the starting point, and then you go to the right for positive numbers, you go to the left for negative numbers. So a horizontal number. But the application coordinate geometry, okay, algebra, geometry, and everything. So that is why we are learning is. So just let me explain to you one by one, okay, that what are the types of numbers and how we differentiate them. Because if somebody says natural numbers, so you must know natural numbers are only positive numbers starting from 1, 2, 3, 4, like that. Okay, and so let me just show you the different types of these real numbers. So your real numbers, they are further subdivided into rational number and irrational numbers. Okay, say rational number and irrational number. Okay, so there are two subdivisions again of the real numbers. One is the rational numbers and irrational numbers. Now both of these constitute what is called as a real number. So real number means what? Real number means it constitute both rational as well as irrational numbers. Now in rational number, what exactly we are learning? So let us see this. Now how to write the numbers? I just explained to you. You start with a benchmark or a starting point with 0, and on the right hand side positive, we say positive numbers, left hand side negative numbers. So we are initially thinking only about the horizontal number line, okay, and then you can write everything, whether rational numbers or irrational numbers, on that number line. As we keep on advancing in this lecture, you will come to know a lot of things. Okay, so this I have already explained to you how to write the numbers, and so let us now come to what is rational number and irrational numbers. Okay, so basically now rational number means they are in the form p upon q, where both p and q integers and q not equal to 0. So just let me write it down. So rational numbers basically are of the form p upon q, okay, integers and q not equal to 0. We do not want the denominator to be 0, because if the denominator is 0, then it is infinity. So we cannot define this basically. So you should not have denominator at 0. And so p and q, where p and q are integers and q not equal to 0. Okay, so they are rational numbers and irrational. So let us see further subdivision of rational numbers. Okay, before we come to irrational numbers, we will again go to what are the subdivisions of again rational number. Okay, so this is basic definition of rational number. So what exactly falls into this category? Okay, so before we start the the actual lectures, okay, before we start the actual lecture, so these are the basic things which one has to know. So now let us see what are the further subdivisions of rational number. Okay, so in the rational number, now see basically now if you see your line, so see we say this is your benchmark or starting point 0, and you are having here positive numbers 1, 2, so on. Okay, that it will go on, right? That is positive numbers. So you have got negative numbers to the left hand side. So -1, -2, -3, and so on. So basically now this goes in both the directions. So this is basically your number line. Now see rational number as per our definition, it is in the form p upon q, where both p and q are integers and q not equal to 0. So if you see this particular, say all these positive numbers, so they can be put on one. Okay, so all of them are rational numbers. Okay, 0. Now 0 is can be also put as 0 upon 2, because 0 upon anything is 0. So 0 is also rational number. So all positive numbers 0, they are rational numbers. Now come to negative side, negative numbers. So negative numbers -1 we can put as -1 upon 1, -2 also -2 upon 1, and so on. So they are in the form p upon q, where q is not equal to 0 and both of them are integers. So all of them form what is called as the rational numbers. Now what are these things called? See, if you see again further, when you got these rational numbers, they are subdivided into positive integers. All these numbers are called as, see, these are called as positive integers, 1, 2, 3, 4, and the left hand side of the 0 is called negative integers. Okay, and 0 is an integer, right? Now 0, so you must know whether 0 is positive or negative. Sometimes people don't know whether it is positive, negative, or what exactly. Okay, some people say it is positive, some people say no, it doesn't have any sign. So basically 0 is neither positive nor negative. Okay, 0 is neither positive or negative. So see, sometimes in the entrance examinations they will say a non-positive integer. So if it is a non-positive integer, you can suddenly conclude that okay, non-positive means it should be negative. No, then 0 also have to be considered. So if it is a non-positive integer, so either it can be negative or 0. So you have to take both the values to see whether a certain statement is valid or not. And same way, if the sum says that a non-negative integer, so if it is a non-negative integer, it just doesn't mean that it is a positive integer, so it can be 0 also. So basically you have to take this difference about non-positive and non-negative integer. So it can also contain 0. So certain times basically when there are sums given, so generally they play with the words, and words means what? You have to have these proper numbers. What is 0? It is neither positive or negative. But when you say non-positive or a non-negative integer, 0 can be one of them also. Okay. So that is how the difference you have to know. So all of these are integers. Okay. So you have got rational numbers. The further subdivision is they are integers. Okay. All of these are integers, positive, negative, or 0. Rational numbers also, they are integers also. Okay. Now again further, your natural number. What is the meaning of natural number? Natural number means only starting from 1, 2, 3, 4. Okay. They are only called as natural numbers. Some of the books, some of the places, they add 0 also as a natural number. That is wrong. Okay. 0 is not a natural number. Only positive numbers starting from 1, 2, 3, 4 up to infinity, we can say they are natural numbers. Okay. So 0 is not a part of natural numbers. Same way now, but 0, supposing if you include with the set of these natural numbers, then they are called as a set of whole numbers. So there is a difference. If the sum says natural numbers, then only you have to take 1, 2, 3, 4. If they say whole number, so 0 also is one of the part. So it can start from 0, 1, 2, 3, 4. Okay. So whole numbers means it includes 0, 1, 2, 3, 4 positive. But natural numbers means only positive numbers, 1, 2, 3, 4. Okay. So you have got natural numbers, you had whole numbers, we had integers. So these are the different types of numbers one has to know. If somebody says natural number means only 1, 2, 3, 4, you cannot take any other thing. If they say integers means the whole lot can come. You can have negative numbers, 0, positive numbers and everything. So that is why one has to know what is the meaning of exact types of numbers. Okay. So this is I have told you. Now let us go further. Now further to this, you have seen integers, positive integers, negative integers, okay, all those things, then 0, rational numbers, and of course then there are certain again further what you say type, like we can say prime numbers, co-prime numbers, okay. So now let us see, for example, now prime numbers, okay, means again in this number system you have different types of things. Prime numbers. Of course, this when we are now seeing the presentation, you will come to know the prime numbers and all this. Just to give an idea, so prime numbers are like 2, 3, 5, 7, okay, 11, 13, and so on. See, basically prime numbers means it will have only two factors. Basically, one is also considered as a factor, and the number itself. So you can 2 you can write it as 1 into 2, 3 you can write it as 1 into 3. There are no other factors. So there are only two factors. 5 is also 1 into 5, 7. Okay. But now 6 or 4, they are not prime numbers, because 6 there are so many divisors or factors like 1, 2, 3, 6. 4, say 1, 2 and 4. So there are more than two factors. So if there are more than two factors, then it is not a prime number. Okay. Prime numbers will have only two factors. Okay. Now sometimes what about 0 and 1? So 0 and 1, they are neither prime nor composite. You see, if a number is having more than two factors, that number is called as a composite number. Like for example, 4. 4 means it has got 3 divisors or 3 factors like 1, 2 and 4. So 4 is a composite number. It is not a prime number. 6, for example, 6. So it has got 1, 2, 3 and 6. So naturally it has got more than 2 factors. So it is again a composite number. Okay. So now 0 and 1, they are neither prime nor composite. So you must know what is the prime numbers, what are the prime numbers, and what is not a prime number. Thing called as a co-prime number also. Also just let you an idea, and then we will start with our presentation. Okay. See prime numbers. Now co-prime numbers, say for example, I can write say 2, 3. They are co-prime. Prime means the HCF is 1. Highest common factor is only 1. Then only they are called as co-prime. So I can have 2, 3, or I can have say 5 and 4 also, no problem. Of course, these are different. 4 and 5 are different. 4 and 5 are co-prime. 2, 3, 5 are also co-prime because only HCF is 1. But 2 and 4, they are not co-prime because the HCF is 2. Okay. So co-prime numbers means the HCF has to be only 1. Okay. They are co-prime numbers. Otherwise, if they do not have HCF as 1, then they are not co-primes. Okay. Because certain examples you have to have whether it is prime, co-prime, and all that. So different types of numbers will be there. Okay. Now you all learned different types of numbers exactly and what we are learning, and now see why we are learning. Important that, as I said in the beginning, why we have to learn this number theory. Everybody knows. I know what is 1, 2, 3, 4, but then what exactly new thing you are trying to teach us or tell us? Yes. Now I agree with you, because if you learn only what is given everywhere, then you won't feel interested, because yes, everybody knows about it. Something to make it interesting, then you must know, there are these numbers are so versatile that when you learn in a different way, so you will feel interested in learning this number theory. Okay. So for example, now why we are learning. Okay. So basically now before that, about something about irrational numbers. Okay. Just to conclude, so that irrational numbers, basically, you see, they cannot be in the form P upon Q. Okay. They cannot be in the where P and Q are integers. So basically, irrational numbers, you cannot put it in the form of P upon Q. So generally this, like for example, root 2, root 3, root 5. Okay. They are all irrational numbers. So basically they are also called as surds also. Okay. They are called as surds also. And so surd means an irrational root of a positive rational number. So surd is an irrational root of a positive rational number. Because why positive? Because otherwise it will go into an imaginary field. So that is why the surd is defined as an irrational root of a positive rational number. So basically, and they are not in the form of P and Q, where both are integers and Q is not equal to 0. So they are called as irrational numbers. But you will, in knowing this, that both rational and irrational numbers can be plotted on the number line. Okay, they can be plotted. For example, root 2. Now, how will you plot root 2? Supposing now you have got, this is a number line, 0. I take 1 unit here, right? And then I draw a perpendicular. And then again I take 1 unit. This is 90 degrees. Correct. Now you come to Pythagoras theorem. When you come to Pythagoras theorem, you join this. 1 square plus 1 square. So that is 1 plus 1, 2. Now you take the square root. So this length, particular length is root 2. Okay, so I can say A here. Now you take an arc. You take an arc like this and draw a compass. So this point becomes root 2. Okay, so that the irrational numbers also can be plotted on the number line. So both rational and irrational numbers. So same way root 2, root 3, root 5, same logic we can do and do it. Supposing if I want to find root 3, from this root 2 I can again draw 1. Okay, from here. This is 1, and now join this. So see, this particular portion is root 2. So using again Pythagoras theorem, square this 2 plus 1 square 3, and So this becomes particular, this B, supposing this point is B, OB becomes root 3. And you draw an arc and you will get root 3 here. Okay. So, yeah. Any doubts you can ask me? Yes. Yeah, that is approximate. See, basically that is good you asked me. See, root 2 value is 1.41, say approximate, and it can be 4 something or little bit less than that, or but it is non-terminating. It's a non-terminating. It is not terminating. So that is why I'm coming to the final definitions of a rational number and irrational number also. Okay. So root 2, it is not a definite, it is not a terminating decimal. It is non-terminating decimal. Okay, non-terminating means it is endless. That is why it is irrational number. Okay, same way will happen with root 3 also. Now, what is the value of root 3? Root 3 is say about 1.732. We take for purpose of approximation. And sometimes we don't take 2, we just be happy with 1.73 because that serves our purpose, right? Root 3 will be 1.732. Okay. No. This is approximate. This is approximate. That's why. It is not, that's what I said. It is not terminating. It is called non-terminating decimal. They are all called non-terminating decimal. So that is why they are approximate value. Even your pi. Pi is how much? You say generally we say it is 22 upon 7. This is approximate value. Okay, so yes. This is 22 upon 7 is an approximate value, but 22 by 7 by itself is a rational number. Just if you say what is 22 upon 7, it is a rational number. Okay. But if you say that what is pi, pi is an irrational number. The approximate value is 22 upon 7. Or in terms of the non-terminating decimal, it will become 3.14 and yeah, okay. 3.14 whatever, yeah, whatever, it will keep on, there is not terminating. So that is only approximate value. Okay. So that is why root 3 pi, for the example, E also, E is approximate value we take is 2.71, but it is an irrational number. Okay. It is, the base of the Napier logarithm. So that is also an irrational number. So it is a non-terminating. So what is the definition of irrational number and rational number in terms of recurring and non-terminating or terminating? Okay. Now what we said rational, say for example, if I take say 2 upon 5. Now 2 upon 5 is how much? It is 0.4. I can take 1 upon 2 also. So this is a terminating decimal. Terminating means stopping. It is not going beyond that. See here 0.4 means it can be 0.40, anything 0, 0. So it is terminating. Anything after that, if you have to put 0, the value remains same. So that is called terminating. So rational number can have terminating decimal, or one more example now, this is terminating, but I have another number which is say 1 upon 3 and recurring. See, so here it is 0.333. So we say it is recurring basically. So what is the definition of rational number in terms of recurring, terminating, non-terminating? So rational number can be terminating. One is can be terminating like 1 upon 2, 2 upon 5, anything 3 upon 5. So it can be terminating or it can be non-terminating but recurring. So rational number definition can be terminating decimal or non-terminating but recurring. Okay. So what is the definition of irrational number? Irrational number is neither terminating nor recurring. So irrational number is defined as it is neither terminating nor recurring. So that is the definition of an irrational number. Okay, so that is how basically you define. So irrational number can be neither terminating nor recurring, but in rational number it can be recurring and non-terminating, or it can be terminating. So this is the difference between a rational number and irrational number. Okay, so now see all these rational numbers, irrational numbers can be plotted on the number line, and that is why, because the number line is a real number line. So that is why we say that real numbers consist of both rational as well as irrational numbers. Okay. So now let us see, coming to the last part of why we are learning these numbers. Okay. So just let us dwell upon. Now you have got the understanding that real numbers, rational, irrational, and you have got prime numbers, natural numbers, whole numbers, integers. Okay. At present, we will not discuss about the fractions and all that. But anyway, fractions we have indirectly discussed in terms of rational numbers. Okay, but that will come. We'll see later. So now let us see why we are learning this number theory. Okay, so why we are learning this number theory? So everyday life we use numbers, right? You go to a shop, you want to purchase something. So supposing you have purchased some 33 rupees. You know, if your mathematics is good, you know that 100 minus 33, you must get 67. Okay, and somebody says, no, I must get 77, then that shopkeeper will shout at you. And if you just say, no, I am happy with 57 rupees, then he's also very happy because he is getting 10 rupees profit. So basically, you have to know that is called as number bonding. So sometimes you see, you'll be wondering that. So that has to stop. You have to learn something called as the number bonding. So number bonding is very important. If I say 28 plus 13, it has to be 41. Simple. So you don't keep on counting. Okay. So same way you have to say 29 plus 14, 43. Or the other way, 43 minus 29, it must becomes 14. So you have to be very fast. Because nowadays, whenever you go for entrance examination, okay, and so it is a test of basically speed and knowledge. You must have speed also, you must have knowledge also. And so you have to learn certain tricks where you can, what to say, shorten the time period of solving it. You have to get correct answer. And of course, you have to be a little cautious also, because if you drive fast, every time it may not be correct. Then you are likely to make an accident. To be very sure that what you are doing is proper, fast and perfect. So every time if you go slow also, then it may not be suitable, because if you can be slow, you may lose the race. So you have to be, you have to make a balance between all this. That is why we have to learn different concepts of mathematics, and so everything starts with the numbers. So basically, why we are learning? Okay. So see now, as okay, yeah. As I gave an example that we of a shop, you go to the shop, and then you buy something, and then you have to give some money, then he gives a change. So you must know, okay. Otherwise, he is very happy if you don't know mathematics, and then he can, give whatever he wants. Okay. So one has to be very careful in this. Okay. Now another thing, just an example of this. Now see how we do this, where we use. Basically, why we are learning comes in the application part of it. So application of number theory. So what is the application of number theory? So let us see one by one. So we start with, say for example, one dimension, or okay, one dimension. Then you have two dimensions. And let me see one as, okay. So these are the applications. Okay, how we do the applications? Yeah. Yeah, no, I am just give you the examples now. Say for one dimension. Now, supposing you want to measure the length of this board, correct? Only length you want to measure. So naturally, it is a single dimension. Or you want to measure the breadth of the board. So it is a single dimension. Okay, so you can measure with the measuring tape. Okay, or if it is very small, you can use the ruler and all that. Okay, so that is a single dimension. So you are able to measure the length. Okay, what is the length of this particular classroom? Okay, so that is a single dimension. It is no, okay, if you want to, my hall has to be like this. I want so much length minimum and so much width or breadth. So this is a single dimension. So these are all applications, correct? Everywhere you will use it, whether in the buying a house or purchasing a table or anything for that matter, right? So that is a single dimension. So where the numbers are used. That is the first thing. Okay. Buying some property, or you want to measure some area. So area is two dimension. So here you see, okay, so this is for the measurement, single measurement. I can say single measurement. A single measurement of say length, breadth, height, anything. Okay, so this is your single dimension. Okay, again you are using numbers. Now supposing you want area. Now you want to buy certain property. You want so much length and so much breadth. Okay, now 500 square feet to 5, or you can say 50 into 10 also. Okay, or supposing, so you have to decide and tell them what exactly dimensions you need. So that is an area. Okay. For example, two dimensions. I will say area. So area 500. I can take 100 into 5 also. I can take 50 into 10 also, or I can take 25 into 20 also. Whichever way I want. So you are ready to decide the dimensions. That is your choice. So you say that I want this type of room should be there for whatever that. Okay. So that is why this application comes as an area. So you are buying something for anything or any other application. So that is area. Then another third thing comes for three dimensions. So volume. Now volume means your length, breadth and height. Supposing if you take, for example, if you take, okay, then you are having, see, if you take say rectangular tank. Okay, so now you basically require volume, right? And how many liters it should hold, or how many cubic meters it should hold. So for that you must know the conversion of different dimensions. Okay, for example, rectangular tank, you can have the volume as length into breadth into height. Okay, length, breadth into height, because see, supposing if you have only length and breadth, then nothing can hold there. If you pour water on that, it will go off. It cannot hold. So volume, concept of volume, why it has come is because it must be able to hold. So it must have length, breadth, depth or height. Okay. So now for example, rectangular tank, you can have cylindrical tanks also. So in this, what happens, this basically this is nothing but the area. Just now we have seen that length to breadth is area. So volume can be area into height. Okay. So cylindrical tank, what is the area? Yeah, base area. So base area of a cylinder, pi r square into h. Okay, so your pi r square radius square into height. So cylindrical tank. Now if you want spherical tank for storing something, again there is a, so sphere. So I will take spherical tank. Yeah. Yeah. So 4 by 3 pi r cube. Correct. So a sphere is 4 upon 3 pi r cube. So basically depend upon that. Because why here r is directly also is height, because for radius, for the sphere, radius is also equal to height. So that's why you don't see h here. Okay. So but otherwise it is related to the height. So basically volume is your three dimensional. Now see, for example, now if you want to construct some groundwater tank for your society, or a overhead water tank, say for example 20,000 liters. So somebody will think, okay, how the dimensions have to be taken. So if you are aware about these numbers and these things, you can easily do it. So now what are the conversion factors? So just I will give you some idea. Okay. So see, for that, if you know what you say uh, proper dimensions, then and the conversion factors, then it is very easy for you to what you want exactly. Now, for example, you see your 1 foot. If you see your scale, earlier Britishers they had scale of inches and foot and all that. So now 1 inch equal to, you can say 2.54 centimeters. Say for example, okay, 1 inch is equal to 2.54 centimeters. Now your 1 foot is how much? 12 inches. So basically it becomes 30.48 centimeter. Okay, so this becomes 12 inch equal to 30.48 centimeters. Now see, we are not so much big things. You are not interested so much in calculating some small parts, 1 foot here and there. Now if you have got 1 foot is so much, 30.48 centimeter. If you take 1 cubic feet, okay, basically coming to meters, that is a system which we are using meters also. So how that is to be done, you can do that way also. Just I am giving an example. So 1 cubic feet becomes basically the cube of this 30.48. You just take 30 cube. 30 means it is 27,000. So 1000 centimeter cube is 1 liter. So you will have 27 liters. So basically, now what about this 0.48? That also have to be, so finally it becomes 28 liters. Instead of 27 liters, it will becomes approximately 28 liters. So if you know this conversion, then you are ready to do anything. So 1 cubic feet becomes approximately 28 liters, right? I will just say 25 liters only, for example, because take liter. So I will take it as 25 liters. Now, if I want, I just talk to you about 20,000 liters. So what I see 20,000 liters divided by 25, approximately. I am taking slightly more volume only because 28 liters will give you 1 cubic feet. But I am taking lower volume so that I can have a bigger capacity. Okay, I can have bigger capacity. So you will have 25 liters supposing. So how much it becomes now, or we can, yeah. So how much that will become? 800. Yeah, 800. So 800 cubic feet. But actual 800 cubic feet will contain how much? 800 into 28. So it will have more volume. That is what I want. Slightly more volume. That correct? That is the idea. So you calculate little less to get a bigger volume for the purpose of calculation. So then now you want to do dimensions. Now you want 800 cubic feet. Now 800 cubic feet is you can take, supposing you want to do three dimensions. So you can take, I can take it as say for 40 by 10 by 10. Sorry, 40 by 10. Okay, sorry. For yeah. So supposing this 800 cubic feet. So I can take it as say okay 20. Okay, 24 feet by, because I will take this 20 feet by 10 feet as my base, 20 feet long and 10 feet wide. That is a tank, and height I will take very less because I don't want too much to go into the sky, right? So 20 by 10 into 4. But same thing, I will get 800 cubic feet. So now you are ready to tell the contractor build tank in this fashion, or you want little bit in a different manner. You want to take it little less. You can do it accordingly. Okay, so that is now cubic feet. Same thing you can convert into meters. Now the present trend we convert into meters. You must know basically. Okay, now just let me rub this. Say for example, now you must know this. Earlier you see 1 yard in the British time. Okay, that is used to be 3 feet. Okay, 1 yard used to be 3 feet. Now 1 meter. Now our present age we are in the metric age, correct? 1 meter is 3.28 feet. So you must know whether meter is bigger or yard is bigger. So now you know 1 meter is there. Also now 1 cubic meter. So 1 meter is how much basically? 1 meter is 100 centimeters. Now again if you how much? 1 cubic meter. So that will become 100 into 100 into 100. So now see 1000 liters. So see 1 cubic meter, now we go to 1000 liters. So now we want 20,000 liters. So simple, I want 20,000 liters. So 1 meter cube is 1000 liters. So 20 meter cube I want. So I want finally only 20 meter cube. Okay, this is nothing but 20 meter cube I want. Now it is up to us how to do it. So you can have basically 20, you can take it say 5 meter by 2 meter by 2 meter also. So 5 meter, approximately 1560 feet, 2 meters and 2 meters height. So you can put anything to get 20,000 liters. So same way you can get 10,000 liters, 40,000 liters, 50,000 liters. So these are all applications. Okay. Now, so application, now you distance covered, you know distance is nothing but speed into time. So what is your speed according what is the time, that much distance you will be able to cover. Supposing you want to go to Pune, it is about say 180 kilometers, and Now you say that, okay, I want to reach in 3 hours. So naturally you will say 16 to 3, 180. But you say I am very comfortable. I am not very much in a hurry. I will just go at 45 kilometers per hour. So I will reach in 4 hours. Same 180-kilometer distance. So like that you should be able to calculate. Okay. And so you will know whether you will reach in time, whether you will be late, when you should start. You see, you have to go backward and what time you have to reach accordingly. So these are basically the applications everywhere. Now you have got, say, in management, just most of the time you now project how much money will be required, how much time will be required. So you like man, machine, material, and money. All these things will come. Correct. So all these things you have to quantify. Everywhere you have to quantify to get the work done. And then as you see the time and the time period. So time what okay, you want to complete the project in 1 year's time. Now you have to keep control over it. Correct, as you are lagging behind or you are advancing, all these things is called your planning and control basically. So every 3 months you check whether you are on the track or not, and then you make. So that is every time we have to quantify and then proceed. So that is the importance of this number theory. Why number theory is that you must know, because everything what you do has to be quantified. You want to do your balance sheet, you have to quantify. For any activity, you have to quantify. Your management projects, you are going to the shop or budgets in your house budget or so you have to numbers. Okay. Okay, you are breaking powers also, so everything will come to that. Okay, so this is the general idea. Now we will basically start with the number theory, right? This is the basic thing. Yeah, yeah, sorry. Yeah, as and when, see, basically now we have seen types of numbers, then how we are to write, basically like everything we'll now see in the present. Okay, what is BOD mass? How to, if certain expression is given, how you should calculate? Like BOD mass is the mathematical operation, like your bracket of division, multiplication, addition, subtraction. Now in C, in our system, BOD mass is there, but in US they are calling something as PEMDAS, PEM. Okay, PEMDAS, but like parenthesis means bracket, exponential. They take multiplication first, which is not correct. Okay, so division has to be first and multiplication. Okay, so this how they have to do, and then how this mathematics becomes interesting. So that I'll be now telling you in our presentation, right? Okay, so now since you know now what basically is your mathematics and number theory, it will be much easier for you to understand the presentation which is coming now. Okay, so now let us see number theory. Yeah, just now I was telling you about the BOD mass. Okay, so operation on numbers. So as and when something comes and related to that, again I will be giving you some idea. Okay, so see, simplification of mathematical expression, that is BOD mass. Okay, so BOD mass means first letter stands for bracket. Okay, whatever is in the bracket, first you have to simplify that. So bracket, then something called as off. Off means multiplication. So what you say, the order is first you have to simplify bracket, then you simplify off, that is multiplication, then division. Okay, it is not multiplication first. So division only if it is off, then they have to be taken, even though it is a multiplication. Okay, division, then multiplication, addition, subtraction. Now for example, you have here 2 plus 3 cube plus 8 upon 2 plus 5 into 7 minus 3, okay, plus 4 equal to. So see here 2 plus 3, 5, 5 cube is 125, right? Then 8 upon 2, that is 4, 9, 129. Then you have got, see there you cannot first 7 minus 3, you have to multiply minus 3, so that is 32. So you have got here 129, 32, 161. Again number, you have to try to do number bonding. It will stick. You have to make an effort. You see, it will stick. You have to make an effort and it will come. And then plus 4, 1. So you are using all these things plus certain things about the way of calculation where we are using number bonding. Okay, so number bonding is a very important thing because if I start using calculator, then I will be losing time. The idea for this is that you see, if you use calculator, it is okay for certain decimal point calculations and something is required. Now you can see here, I will give you an example. In US, they are teaching everybody only on the calculator. Everybody, or they will not tell you 12. They will put the calculator and say 3 into 4. That is whatever answer he get. If he makes a mistake, that is gone. Okay. So what? Acha, but what is the now paradox? See the paradox. See the education system is learnt on calculators. But what happens when they give entrance examination for GRE, GMAT? So calculators are not allowed. So what you will do that time? Because you are handicapped that time. So you don't know that what the way we are learning everything. No, and so they face a problem. So you that so mathematical complicated calculations. Fine. So that is the idea. Okay. So and now division is reverse multiplication. You must know if you are dividing something by something, so division is reverse multiplication. Let me give an example for division is reverse multiplication. So supposing now 3 upon 5, okay, this you have to divide 7 upon 5. Division is nothing but reverse multiplication. So this you can write this is as it is, this reverse multiplication. So your answer becomes 3 upon 7. Division is reverse multiplication. But here you have to take care. You see sometimes what happens that you are tricked sometimes. So you do not know what to do. So what is that situation? Supposing they will say now it is 3 upon 5. You divide this by 7. Okay. And that person doesn't know what to do. He thinks that division is reverse multiplication. So he multiplies this by 7. That is wrong because 7 is nothing but 7 upon 1. And now you do reverse multiplication. So this is nothing but now 3 upon 5 into 1 upon 7. So finally this 5 and 7 becomes multiplication. 35. So that is 3 upon 35. So here one has to be careful because most of the students have problems in understanding these type of things. Right? Okay. Now let us see. Okay, so now I have told you about this. Let us go to the next this thing. Yeah. So operations on numbers we have seen. Okay, so let us go further. Divisibility rule. Now see, most of the times your entrance examination also they are using this principle that whether you are able to apply these rules or not. Basically, first is knowledge. What we are learning today is the knowledge. At the same time, the applicability. Okay. So now let us see. When you say that the number is divisible by 2, so it has to be even number. So the last digit has to be 0, 2, 4, 6, 8 like that. Okay. Then only it is divisible by 2. So then it is, so the number is divisible by 2 provided its unit digit is either 0, 2, 4, 6 or 8. Okay. Now divisible by 3. Some of the digits should be divisible by 3. Okay. Now somebody may ask, yeah, I agree that you know that if the number is divisible by 3, okay, then they may say if you know the number is divisible by 3, the sum of the digits should be divisible by 3. But then somebody will ask, sir, I understand this, but can you tell me why only sum of the digits and not some other addition or subtraction? They will ask. Then if you don't know, then they will say, oh, yes, he knows only thing, the rules, but he doesn't know what is behind it. So it should not be like that. If you know something, you have to know perfectly. So why it is sum of the digits should be divisible by 3 and not that, okay, I have some number A, B, C and not why only A plus B plus C and not why not A plus 2B plus C or 2A plus B plus C. So you must be able to explain. Okay, so let us see how that sum of the digits should be divisible by 3, then only the number is divisible by 3. Okay, so basically what we are trying to do here is to understand the rules, also how they have come. Okay, that is important. So now let us see For example, you have got a number. For example, let me take only 2 digits. For example, okay. Let me first take only 2 digits. Then I will go for 3 digits, and then the same thing can be expanded further. Okay. So now see, 2 digits I take. Now this is a 2 digit number. It can have any value. So now what is the value of this number? AB. It is 10A plus B. See the value of this. This is a number. Okay. 2 digit. Yeah. This is a 2 digit number. Correct. And so value. We say value. So value will be 10A plus B, correct? Value will be 10A plus B. Now you split it. Now you split it. This is nothing but 9A plus A plus B. Now 9A is divisible by 3. So only if A plus B is divisible by 3, then the entire number is divisible by 3. So that is why it is divisible. Now let us take 3 digit number. Okay, ABC. So this is a 3 digit number. What is the value? 100A plus 10B plus C, correct? So again do the same operation. Here I take it 99A. So 1A is remaining. This I take 9B plus I will take C, sorry, B and C, 1 minute. So this is 9B and plus B plus C, okay. So now see, this is divisible by 3. This is divisible by 3. So only if A plus B plus C, if it is divisible by 3, which is remaining portion, then the entire number is divisible by 3. Okay. So that is the logic behind it. You see why only some of the digits should be divisible. So this is the logic and the mathematics behind it. So you must know a particular thing as why also, not that, okay, this is the rule, so I am taking it. No. So this is a divisibility rule for 3, right? We'll go further. Yeah, right? Okay. Now, say 4. Okay. Now, let us go. Let us go now for the divisibility of 4. Okay. So, see, your last, when you say that the number is divisible by 4, that its last 2 digits should be divisible by 4 or it should be 0, 0. Why 0, 0? Because your 25 into 4, see, 25 into 4 is 100. So if you have 2 digits which are 0, 0, then any number you put behind, it will be divisible by 4. Okay, so basically 25 into 4 is 100. That's why if you have last 2 digits as 0, 0, it is divisible by 4. So if I take 300, yes, it is divisible by 4. If I take 500, divisible by 4. Okay, so like that. So this or last 2 digits should be divisible by 4. Then the entire number. Suppose I take 12. I can, sorry, if I put say 12, and it is divisible by 4, I can put now any number. I can put here say 0, 3, anything. 30 may not be divisible by 4, but the entire number is divisible. So you have to know the last 2 digits should be divisible by 4 or it should be 0, 0. That is why 25 into 4 is this thing. Now application, how the application comes. You see how that ask you in the entrance examination. So just let us see this. So supposing they give something like that, and there are so many numbers are there, okay, and one of the numbers is 16, other numbers are say 21, something like that only they will give, okay, 23, this and that, and say 15, or I can take it as 0, 2, something like that, similar type. Last digits only are there giving. They say that the number has to be divisible by 4. So which is the number? And there will be only one option. So you see, if your last 2 digits are divisible by 4, it is entire number is divisible by 4. So your answer is this. But there you get confused whether it is 0, 2 is divisible, or sometimes they will some other also. So they will say 10 also. 10 is not divisible, but you may feel it may be divisible. No, last 2 digits either 0, 0 or it is divisible by 2. Then only the number is 4. So see, everything is an applicable, and moment to somebody who is able to answer, he gets selected and he goes ahead. So that is the idea. You have to know everything, and that is the importance of the number theory. So let us see again the same slide. Now we have seen 2, 3, 4. Same way, if the number is divisible by 5, the last digit has to be either 0 or 5. Okay, so that is the thing. Now coming to 6. Coming to 6, how we say that the number is divisible by 6? So first is, it is an even number because 6 is there. Okay, it has to be divisible by, it means 2 even number and divisible by 3, not or. So even and divisible by 3, then it is divisible by 6. Now 7 we do not know at present, okay, anything which is, and that is not really important, the divisible by 7, okay. So that will come at a later stage, we will not immediately talk about it, okay. Now we talk about 8, divisibility by 8. So just like 25 into 4 is 100, so you must know that 125 into 8 is 1000. So you should know that 125 into 8 is 1000. These figures are very important. So if 1000 is divisible by 8, 3000 is divisible by 8, 5000 is divisible by 8. So any number is divisible by 8. So how they give you the entrance examination, how they will give you sum, either last 3 digits 3 or last 3 digits should be divisible by 8, then only that number is divisible by 8. Okay, so last 3 digits, not 2. So for example, they can give you any number. I will just take it at random, or I can take it 104. Okay, so this number either 128. Now last 3 digits 128, you know 16 8s are 128. So if you know the multiplication tables, then you are able to do it very fast. Okay, and now 104, 13 8s are 104. So if you know the tables, you know you can. So this number is divisible by 8. So either this, or what will happen, they will say whether certain, if you divide by 8, what is the remainder? This is one thing. Otherwise what they will say, they will just change this. They will change this 129, okay, or 106. They will say if you divide this number by 8, what is the remainder? So you just consider last 3 digits, because up to this that will be 1000, that will be divisible by 8. So what you are interested now, only last 3 digits. So you know now 16 into 8 128. So remainder is 1, simple. Or here 13 8s are 104, 2 is remainder, 2 is remainder, like that. So you don't have to worry, this number is very big, but you have to only consider last 3 digits, because up to last 3 digits that thousands is divisible by 8. So this is how they give you the sums in entrance examination. Okay, this is the rule, use of these divisibility rules. Okay, let us see further. Okay, fine, this I'll rub. Okay, so now let us see the divisibility by 9. Okay, now for 9, some of the digits should be, okay, some of the digits should be divisible by 9, like 3 only, but here also the same thing applies. It doesn't apply to 6, but it applies to 3 and 9. Okay, some of the digits should be divisible by 9. Okay, now see, there is a specific property of this number 9. Okay, now what is this property? That if you take any number and its reflection, so reflection means what? For example, I'll just show you. Say I'll take any number. For example, say 478. This number itself may not be divisible by 9. Fine. Okay, that's okay. This is a number. Now you have to take reflection. So what is the reflection of this? I will take, you have to just take reflection. 8574. Correct? 8574. Just reflect. Subtract this number from this or this number from this, whatever that. So it will be divisible by 9. So now I subtract this from this, so I'll get a negative number. So I'll just write and subtract. So 14 minus 8, I'll just write it here. 8574 minus 4758. So 3816. So your answer is here. Whether it will be divisible by 9, just add. 11, 12, 6, 18. 18 is divisible by 9. So the entire number is divisible by 9. So now only it will be minus instead of plus. Either you do this way or that way. So any number, so it is 2 digit, 3 digit, 4 digit, 5 digit, anything. There is no restriction. Don't think that only for 4 digits or 2 digit is there. You take 3 digits also, 5 digits also. You take a reflection, subtract. That number will be divisible by 9. So this is a special property of 9. You see, this comes in the entrance examination. So you know whether this thing which will be divisible by what. So because you don't have time that much to really think at that particular time, they will be giving some options. So a number and its reflection, when you subtract, the final result will be divisible by 9. The numbers itself may not be divisible. That is not required. Okay. The numbers itself may not be divisible by 9. That is not required. Only any number and its reflection. So whether it is 2 digit, 3 digit, 4 digit, 5 digit, it doesn't matter. Okay. So this is the property of 9. Okay. So now you can take any digit. Okay, it will come. Let us see 10 and 11. Okay. See now 10, if a number has to be divisible by 10, the unit digit has to be 0, correct? Unit digit has to be 0, then it is divisible by 10. Okay, now coming to divisibility by 11. Okay, so okay, another thing, this is for you know whether the number is a perfect square or not. But before that, let me just tell you how whether a number is divisible by 11 also. Okay, because that is quite interesting. So let us see that. So divisibility by okay, now see supposing I take again any number and say for particular number is there, say x, 5-digit number. It can be applicable to any digit. Okay, whether it is 3 digits, 4 digits, 5 digit, all that. So basically, you start from the right hand side. So if you start this number plus this number plus this number should be equal to this plus this. So now 5 plus 2 is 7. So I have got here 3 plus 1, 4. So here I have to write 3. If I write 3, it is divisible by 7. Okay. So here I write 3 and you see divisible. Now divide 35 by 11. So 33, 2, 9, 8. How much is that will be? Yeah, how much? 2, 10. Sorry, 10. Then again it will be divisible. Okay. So the entire number is divisible by 11. So that is the rule that you start from the right hand side. Now it can be 4 digit also. So you know in the entrance examination they will say should be written here so that it is number is divisible. Now you take in between supposing and here. So now you know same way this is 4 plus 5 9. There should be 8 plus 1. So this number will become 8. Will be divisible by 11. Okay. So you have to start from that. So that is a divisible by 11. So you see this is how they ask in entrance examination. Now this number instead of here it can be here somewhere. No problem. You have to only so this supposing I'll put it 8 here and here that number will not be there. Again same thing 8 plus 1 9 this should be 5. So that is a divisible by 11. Up to 11 it's quite fine. So if you want to see the divisible by 12, 15 it's called compound divisibility. So if a number has to be divisible by 12 it has to be divisible by 3 and 4 both 3 and 4 or of course 6 and 2 but instead of that 3 and 4. So 15 it should be divisible by 3 also it should be divisible by 5 also. Okay. So these are the important things about the divisibility and most of the times they have the questions for your entrance examination. Okay. So now let us go further. Yeah. Now see important number. Okay. Now how to say whether it is a perfect square or not. Now if your unit digit is 2, 3, 7 or 8 of any number, whether it is 2 digit, 3 digit, 4 digit, whatever. If your last digit is 2, 3 or 7, 8, it is not a perfect square. Not a perfect square. So this you have to remember. Okay. Now, so that is the one thing and from that as far as 0 is concerned, naturally 1 0 will not make it a perfect square, but sometimes 2 0 also may not make perfect square, because with two zeros or 2 and 4, 6 zeros, whatever it is, the number attached to that has to be a perfect square. Then only it is divisible by, it will be a perfect square. For example, now if I take, see, now 0 0. Now, if I put 1, it is a perfect square. 1 is perfect square. So 100 it is square. If I take 400, yes. But if I take 300, no, we say it is not a perfect square. So even though it has got two zeros, it is not necessary that it has to be a perfect square. Okay, because 100 is a square or 400 is square. So the number attached before these two zeros also has to be a perfect square. Then only it will be a perfect square. Okay. Yeah. So let us go further now. Yeah, coming to now, prime numbers, as I discussed earlier, okay, has only two factors. So say for example 1 and 2 or 1 and 5. So I said 2, 3, 7, 2, 5, 7, 11, 13, all are prime numbers because they have got only two factors. Okay, so composite numbers has more than two factors. Okay, say for example divisors of 4, 1, 2, 4. Okay, so it is more than two factors, so it is not a prime number, it's a composite number. Okay, so same way, now here is also considered as factor. Okay, now co-prime numbers, as I told you earlier, so it must have HCF as 1, then only they are co-prime, means a pair of numbers or whatever is. Supposing 2, 3, they are co-prime, 2, 7 also co-prime. If I take three numbers, say 2, 3, 5, also they are co-prime because HCF is 1. I can take 2, 3, 5, 7 also, that is they are co-prime. Okay, so that is the meaning of co-prime. So let us go further. See here, these are entrance examination questions. If sum or difference of two prime numbers is a prime number, okay, sum or difference of two prime numbers is a prime number, then 2 has to be one of them. You see, for example, 2 plus 5, both numbers 2 and 5, 7 is also prime. So if all the three are prime, then it has to be 2. So for example, 13 minus 11, it is 2. So if sum or the difference of two prime numbers is a prime number, then one of them has to be 2. One of them has to be 2. Okay, otherwise it will not work. So this is very important. Now, another, only one prime triplet of the form 2 n plus 4. Now all these things come as application and entrance examination questions. Okay, so n plus 2, they will ask how many numbers are there of this form, n plus 2, n plus 4. Okay, prime triplets. So only you have got one, that is 3, 5 and 7. You cannot have any other prime numbers of this category. Okay, means they have to be primes basically, the prime triplets. So only n plus 2, n plus 4, only 1, 3, 5 and 7. Now as I told earlier, 0 and 1 are neither prime nor composite. Okay, they are neither prime numbers or composite numbers, right? Okay, so let us go further. So see, now something interesting is coming. Okay, now for example, if you take, because as I said, everybody knows numbers, but then something, if it is interesting, then you also are drawn towards that. Okay, so for example 1, you take only odd numbers. 1 is an odd number, and generally in the entrance examination people just don't think about 1, they start thinking from odd numbers, means from 3 onwards, 3, 5, and there only they make the mistake. So you should not forget that 1 is the first odd numbers and it is very, very important. Okay, so now coming to odd, now 1 is equal to 1 cube. Okay, fine. Now you take another two odd numbers, 3 plus 5, 1 number, so 1 cube, 3 plus 5, 2 cube, the sum is 2 cube, 8 numbers. You take from that 7, 9, 11, it is 3 cube. So like that you can keep on expanding. You take 13, 15, 17, 19, it will become finally 4 cube. Okay, so like that. So it becomes, now mathematics becomes interesting if you know that okay, these numbers fall like that in a particular order. Okay, so one odd number, 1 2 cube, 3 cube. Now if you take, say for example 13, 15, 17 and 19, that you will find that is becoming 64. Okay, so 13 and 15, 28, and 17 and 19, that is 36. 36 plus 28, 64. So like that, the sequence that comes. Okay. Now let us come to the sum of odd numbers. Okay. If you take one odd number, see 1 is equal to 1 square. Now coming to the next. Okay. 1 is 1 square. Now take one more odd number. 1 plus 3, two numbers, 2 square. Take 3. 1 plus 3 plus 5, 3 square. 3 numbers, 3 square. Like that. 1 plus 3 plus 5 plus 7 will become 4 square. So see, these are the tricks which you are supposed to know and apply as and when they are called for. Okay. So now this makes mathematics interesting. Now let us come to one particular. Now see, 3 cube plus 4 cube plus 5 cube is 6 cube. But see, there are only few numbers like that. You cannot say that 1 cube plus 2 cube plus 3 cube will become 4 cube. No. Okay. So you cannot say some other numbers, consecutive numbers. But this is one particular thing is there. That 3 cube plus 4 cube plus 5 cube becomes 6 cube. Okay. Now come to, in your algebra books and number books, arithmetic books in your schools and all that, they have derived this, like sum of first n natural numbers, 1 plus 2 plus 3 plus 4 and on up to n numbers, n into n plus 1 upon 2. Okay. So that is fine because you add and take another one, constant difference and all that. If you see how they get the sum of the squares or sum of the cubes, then it is too long a process. But now you see the observation. Now again, 1 cube is 1 square. You take 1 cube plus 2 cube. 1 plus 8, 9. That is 1 plus 2 whole square. Correct? Two numbers cube. The third, 1 cube plus 2 cube plus 3 cube. It will be 36. That is 1 plus 2 plus 3 whole square. And finally you get, so sum of the cubes. If they ask, 1 cube plus 2 cube up to 11 cube. What is the answer? So see, I'll just write to and tell you. They will say in the examination 1 cube plus 2 cube plus so on up to 11 cube. What is the answer? Now you cannot keep on doing all this. So your answer is here directly n into n plus 1 upon 2 the entire square. So simply now you put n equal to 11. So 11 into 12 upon 2. Now simplify this, 6 and square. So your answer is 66 square. Simple. So see, this is how you have to know the most basic things, because your brevity is important. You have to save time and you have to be accurate and perfect also. So that will be known only by having knowledge. Once you have knowledge, then only you can apply it. If you do not have the knowledge, then you struggle to find out what is happening. So that is why the importance of these numbers. Okay. So now let us go further. Okay, so see, this makes now mathematics interesting. Now you see, there can be so many things, which you feel that yes, there is something which is very important. Okay, so let us go further. The concept is used to find unit digit or remainder. You see, in entrance examination, whether it is GRE, GMAT, SAT, CAT, and all that, so they will ask you certain things. What is the remainder? Okay, or digit. Now see, if x is a number whose unit digit is 1, 5 or 6, then unit digit of x raised to n is 1, 5 or 6 only. So supposing 1 raised to any number, unit digit will be 1 only. Okay. Now if you have say 11 or 121, 131, whatever you want to put a power, the last digit will become 1 only. Okay. Same thing will happen with 5. Now 5 raised to 1 is 5, 5 raised to 2 is 25, so 5 raised to 3 is 125. So last digit will be 5 only. Any power you raise. Same thing with the 6. Now 6 raised to 1 is 6, 6 square is 36, 6 cube is 216. So last digit will be always 6. So these are the three numbers which you are supposed to, concentrate. Okay, where I will get 1, 5, 6. And then you get the answer immediately. For example, now let us take some example. Okay. While finding the cyclicity, that is called as a cyclicity. Cyclicity means the final numbers should come in this form, either 1, 5 or 6. And then you know what is the unit digit or what is the remainder. Okay. Now see, cyclicity of 2, 3, 4, 7, 8 and 9, for example. Now what is 2 raised to 4? 16. Moment you get 6, you have to stop. And then you raise it to power and then you can find out the remainder. 1, 5 or 6. 4 square, 16. You stop. Because then 6 has come. And then any power you raise, 6 raised to any power, last number will be 6 only. So accordingly you manipulate. Okay. Then you take 8 raised to 4, 8 8s are 64. Now 64 and 64, last digit is 4, 4, so it will become 16. So that is called as a cyclicity. Okay. So unit digit is 6. Now what about this 3 raised to 4? See, 3 raised to 4 is 81. So if you have got something to the power of 3, supposing for example, say for example 3 raised to 20. Okay, just instead of 3 raised to 20, because more. Say for example, now this is 3 raised to 4. A raised to m raised to n is a raised to mn. So now since this is 81, now unit digit directly, you know, it is 1 only. Unit digit of 3 raised to 20 is 1. Now if you think 3 raised to say 20, 2 for example, okay, or 22 say for example. So 3 is equal to 3 raised to 20 into 3 square. Now the unit digit of this is 1, this is 9. So finally it is 1 into 9, 9 only. Unit digit will become 9. So like that you have to see, you know, that come to first 1, 5 or 6 and then bifurcate and then you will get the answer. Okay. So that is the importance of this cyclicity and the unit digit or the remainder. So accordingly you can find. So let us go further. So unit digit and remainder. Okay. So yeah, next slide we'll see. Okay, sum perfect number. So what is the meaning of perfect number? So we had discussed different types of numbers. See, sum of divisors including the number, it should be number. For example, divisors of 6 are 1, 2, 3 and 6. Okay. Now if you take their sum becomes 12. 1, 2, 3 plus 6, it is 12. So it is double the number. So if the sum of the divisors is double the number, then that number is called as the perfect number. Okay. So you have got 6, 28, for example, 496 are perfect numbers. Now what is the formula? The formula for the perfect numbers is like this. 2 raised to n minus 1. Okay. N is a prime number. Okay, n is a prime number. So accordingly, you can easily find out first will come 6. Now if you take, for example, 3, then that will be 7 into 4, 28 and so on. Another important thing, all these things will come for your entrance examination. Okay, reciprocals of divisors of perfect number. See, reciprocals of divisors of perfect number adds up to 6. Adds up to 2. Say for example, now you take 1, 2, 3 and 6. If you take the reciprocals, so you will have, say for example 1, so 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 6. Correct? Your LCM is 6. So 6 plus 3, 9 plus 2, 11 plus 1, 12. So if you take the reciprocals of the divisors of a perfect number, it adds up to 2. So these are the things. Now 28 also similar way it will happen. So 28 you can have, you are having 1, then 2, 4, then another thing, yes, 7, 14 also. 1, 2, 4, 7, 14, 28. Have I missed anything? No. Fine. Correct. So this will be, now again you take 28 and you will see that this is 28. So you add 28 plus 14, 42, 49, 53, 55, 1, 56. Okay. So sum of the reciprocals will become equal to 2. Right. So this is about perfect numbers. Right. Yeah. Yeah. Okay. So now, so let us see further. Yeah, and this formula you have to remember, which can be perfect numbers, is 2 raised to n minus 1 multiplied by 2 raised to n minus 1. N is a prime number. Okay. So now let us go further. See, this is called as Fermat's theorem. Now sometimes, you know, you are not ready to know what exactly is to be done. So in that time, this helps you. Your CAT examination and all. Okay. So for management, if P is a prime number and Q is a natural number, then P and Q are, when P and Q are co-prime as I told you that their HCF should be 1, then Q raised to P minus 1 is divided by P, the remainder is 1. Okay. So if Q is equal to 4, and when it is divided by raised to 100 is divided by 101. Now 101 is a prime number. Okay. And so you get, this is 2 into 100, that is 101 minus 1 as per this formula. Okay. As per this formula, then straight away your remainder becomes 1. Okay. So this is called as Fermat's theorem. So certain things you have to remember. Okay. Let us go further. Okay. Now factors or divisors of a number. Okay. Factorize the given number into powers of prime number. So supposing you want to find what are the factors, first is you make the factors as the factors powers of prime numbers. Okay, supposing n is a number, so put it in the form a raised to p into b raised to q into c raised to r. Okay, where a, b, c are prime numbers. You have to put only a, b, c as prime numbers, powers of prime numbers. Okay, now so how many factors will be there? It is very simple. You take the exponents, keep on adding 1 to that. So p plus 1 into q plus 1 into r plus 1. Okay, that r plus 1 has not been shown there, but it is p plus 1 into q plus 1 into r plus 1. If there are only p and q, then it is p1, p plus 1 into q plus 1. So for example, 6 is equal to 2 into 3. So 2 raised to 1 into 3 raised to 1. So now p is 1, q is 1. So p plus 1 is 2 and again q plus 1 is also 2. Totally 4 factors. So 1, 2, 3, 6 are factors of 6. Total 4. Okay. So like that. For example, now if n is 120, so you have got 120 means you can say like 5 into 3, 15, 15 8s are 120. So 15 8s, 8 means 2 raised to 3 into 3 raised to 1 and 5 raised to 1. Okay, so if you know the tables, you can do it fast. So now we have got P as 3, Q as 1. So 3 plus 1, 4, 4 into 2, 8, 8 into 2, 16. Correct? So that will be the sum of the divisors. Sum of the divisors, so there is another formula. It is called a raised to p plus 1. Once you have found out in this, then you use this a raised to p plus 1 minus 1 multiplied by b raised to q plus 1 minus 1 c raised to r plus 1 minus 1 upon a minus 1 into b minus 1 into c minus 1. Okay, so this is the sum of the divisors. Say for example, factors of a number, sum of divisors of 120 are. So finally you will get this is equal to 2 raised to 4 minus 1, 3 raised to 2 minus 1, 5 raised to 2 minus 1 divided by 1, 2 into 4 like a minus 1, b minus 1. So finally 360. So these are the things which are asked in the entrance examination. You see why we are learning all these things is they want to, you see everybody is there and there is a heavy competition. So they want somebody who knows everything. So they are doing a process of elimination. So in the process of elimination, if somebody doesn't know certain things, he goes behind, and somebody knows everything, he goes ahead. So that is the importance of learning all this. Okay, let us go further. Now, numbers of particular digit, numbers of multiples. How many numbers from say 1 to 100 have digits 7 or 5 sometimes? Now that time it is not possible for you to write down everything. So there are certain things is like this. Same digit appears 2 times, only once 19 times, because one more time it is double. Okay, once 19 times. Multiples of 13. Now for this is particular, this part is different. So how many numbers 1 to 100 have digits 7 or 5? So like that. Okay. The multiples of 13 between 200 and 300. So what you should do, just take higher number, say 300 by 13, and you take only quotient. So you get quotient as 13 to the 26, 13 3 the 39. So don't worry about that one. You take only quotient. So you get 23, and same thing you do with 200. So you get 200 by 13. So 13 ones are 13, 7, 13 5s are 65, and you are left out with 5. Don't worry about that 5. So you get 15. So 23 minus 15. So answer is 8. Simple, like that. So this is how many multiples of 13 between, you have to follow this procedure. Okay. Now simultaneous division method to find HCF and LCM. You see, earlier what we used to do, if we have some number, we have to factorize them. One factorization and another factorization, and then we used to take common factors. So that was HCF, and common factor into uncommon factor was becoming LCM. Correct? Common factor into uncommon factor is become LCM. So, for example, how we used to do earlier, just I'll give an example, and then we come to this simultaneous division method. See, 16 is there, so we'll immediately factorize. Because prime numbers which are factors, they are called as prime factors. Okay. So now 16, then say 24. Again I'll put 2. Okay. So you have got another one. Now you have got another number we had, I think, how much? 36? Yeah. So again I'll put 2. Correct? We used to take common numbers. So common numbers is now is 2 into 2, 4. So 4 becomes your HCF. Okay. Because they were common to all the three. And now common and into uncommon. So finally you will get this common. And then you have got here, so 4 is there, correct? Then what about these, all these numbers you will have to put again. So 4 into 2, 8. 8 into, I can put 3 into 3 into 3. Is it something more I have taken? Sorry, here I have made a mistake here, so that first I write. Is it correct? No, it is correct. So first is, this is 2 into 2, 4. Okay. And what about other numbers? No, LCM, LCM, LCM. Yeah, yeah. So correct, correct. So yeah, yeah. So that's why. So finally, how much you will get? That will be 4. See here, you will have 4, and then you will have further again all maximum, that is 4. Again 3 into 3. Correct. So finally, you will get 16 into 3, 48 into 3, 144. Correct. So you will have answer as 144. So let us see here. Yeah. So let us see how we do by simultaneous division method. Oh, sorry. So simultaneous division method, what you write these numbers 16, 24, 36. Okay. Now you can start dividing by any number. Okay, like 2, 3, 4, whichever is divisible. So now 4 is divisible. It is obvious. So we divide by 4. So we get 4 4s are 16, 4 6 are 24, 4 9s are 36. Now if any two numbers are divisible by any other number, prime factor, then you have to take that number. So now for example 4 and 6, it is divisible by 2. So start with 2. 2 2s are 4, 2 3s are 6, 9 keep as it is. Then now again between 3 and 9, you have got two numbers which are divisible by 3. So divide by 3. So 2 keep it as it is. 3 1s are 3, 3 3s are 9. So this is your HCF already come. And now 4 into 2 into 3 and last line 2 into 1 into 3. So finally it becomes 144. So this is a very good method and very time saving method, because this takes lot of time. You know, our earlier method. So nobody does in this, you know, only by simultaneous division you get HCF and LCM. Okay. So this is the method of finding out simultaneous division. Okay. So let us go further. Prime and composite numbers I have already discussed, but let us just, of course, just now natural numbers I have told you. Okay. Like 1 2 3 4 and all that. Okay. So natural numbers, all positive numbers starting from 1 2 3 4 5 6 7, right? Then anything is there. Yeah. So see, when a natural number can be written as a product of other natural numbers, the number is the product called as factors, okay, of the original number. For example, 5 and 7 are factors of 35, naturally, correct? It's quite okay. So fine. A natural number A is divisible by B if B divides A with a remainder of 0. See, if your remainder becomes 0, then only that is a factor of that. Okay, that we have seen in algebra also and arithmetic also. Same thing. Okay, suppose if some polynomial is divisible by another polynomial, if the remainder is 0, then only it is divisible, otherwise not. So same thing happens with the okay. Prime numbers, I think I have told you already. A natural number a greater than 1 is called prime if the only way it can be written as a product of natural numbers is 1 into a. The only factors of a are 1 and a itself. I told you already 2, 3, 5, 7 and all that. They are prime numbers. Natural number is composite if it has other than 1 and itself. There are more than 2 factors. Okay. So for example, 23 is a prime since the only way it can be written as numbers 23, but 24 can be written as now so many, not only 4 and 6, it is starting with basically 1, 4 and 6 and all that. Okay, 1 has to be included also. So that is composite. More than 2 factors. Okay, prime factorization. As I told you just now, if you have got divisors or factors as prime numbers, then they are called as prime factors. So fundamental theorem of arithmetic, if the order of the factor is ignored, there is only one way to write a natural number as a product of prime numbers. Okay. For example, 700 can be written in the following way. You always start with first 2, whether it is divisible. Otherwise, go by 3, 5, like that. So 2 into 2, because 25 into 4 is 100. So 4 is a factor. Then you have got 5 into 5 again, 25 and 7. Correct? You get straight away. The prime factors of this. Basically, now if it is repeated, you don't have to write 2 times, only once, 2, 5 and 7. Right. Factor trees. So prime factors of a natural number can be found by constructing a factor tree. Write the given number as a product and continue to factor each composite number until only prime numbers are remain. Like this we have done also. Say for example, so first is we can do anyway 8 into 5. Then again keep on subdividing 8, 4 into 2 and 2 into 2 like that. And so that will be your, this numbers will become your factor tree. So this is called as prime factorization of 40 is determined by the prime numbers at the bottom of each branch of the tree, right? So now we will have a break for 5 minutes and then we will continue with our remaining lecture, right? Yeah, okay, yeah, okay, okay. So now greatest common divisor, so we'll start this after the break, right?